Hello everyone, my name is Mashuk. I'm from Praxis Business School, the class of 24-26. So today the topic that I'm going to talk about is transparency trade-offs in artificial intelligence. So let's imagine a situation where you apply for a loan, you have a stable job, a decent income, a good credit history, yet within seconds an automated response rejects your application. You ask why. The answer you receive is simple and frustrating. The system made the decision. You no explanation, no reasoning, no accountability. Now imagine the same situation, but this time the decision affects a medical diagnosis, a payroll hearing, or a hiring process. This is where the conversation about transparency in artificial intelligence begins, not in theory but in real human consequences. Today, I want to talk about the transparency trade off in AI, why transparency matters, why it is difficult, what we gain by pursuing it, what we lose by enforcing it, and how we might strike a responsible balance. At a basic level, AI transparency refers to our stability ability to understand how and why an AI system makes a decision. In traditional software, transparency is relatively straightforward. If something goes wrong, we can inspect the code. The logic is explicit. It's like following a recipe step by step. Modern AI systems, especially machine learning models, work differently. Instead of being explicitly programmed, they learn patterns from historical data. Their decision making process is often distributed across millions or over billion parameters. This is why many AI systems are described as black boxes. You can see the input, you can see the output, but the reasoning behind that, it's quite difficult to understand. Transparency is often discussed alongside related ideas such as interpretability and explainability. While these terms differ slightly, they all point toward the same concern. Can we understand AI well enough to trust it? Why? Now, the question comes, why transparency matters. Transparency is not just a technical preference, it is a social, ethical, and legal necessity. First, let's understand what is trust in transparency. People are most likely to trust systems that they understand. If AI is going to influence decisions about our lives, our health, finances, or freedom, but blind trust is not enough. Transparency builds confidence that the system is behaving reasonably and consistently. Second, fairness and bias. AI system learn from historical data, and history often contains bias. Without transparency, and biased outcomes can remain hidden. Discrimination can be scaled silently and efficiently. Transparency allow researchers, regulators, and affected individuals to question and audit decisions. Third, accountability. When an AI system causes, who is responsible? The developer, the organization, the regulator. Without transparency, accountability becomes nearly impossible. Laws like in GDPR in Europe already recognize this by granting individuals the right to an explanation in automated decision making. Fourth, and safety reliability. In high stake domains like healthcare, aviation, and criminal justice, understanding how a system behaves is essentially or for detecting errors before they cause serious harm. So transparency clearly matters. But here is the key point. Transparency comes with trade-offs. The core trade-offs in AI transparency. First and the most discussed trade-off is accuracy versus transparency. In many cases, the most accurate models, such as deep neural networks, are also the least interpretable. Simpler models like linear regression or decision trees are easier to explain, but they may not capture complex patterns as effectively. This creates dilemma. Should we choose a slightly less accurate model that we understand or highly accurate model that we do not? If in a movie recommendation system, the answer might be obvious, accuracy matters more. But in medical diagnosis or sentencing decisions, the trade-off becomes ethically challenged. The second trade-off is performance and scalability. High transparent systems often require traditional computations, constraints, or human oversight. This can slow down decision making and make systems hard to deploy at scale. In fast moving environment such as fraud detection or cybersecurity, delays can be costly. The third trade-off involves intellectual property and security. Organizations invest heavily in AI models. Full transparency may expose proprietary techniques or make systems vulnerable to manipulation and adversarial attacks. Revealing too much about a system works can allow malicious actors to game it. The fourth trade off is more subtle, the illusion of understanding. Sometimes explanation simply reality to the point of being misleading. A model might provide a neat explanation that satisfies a human audience while hiding deeper complexity. In such cases, transparency can create overconfidence rather than genuine understanding. So the challenge is not simple without to be transparent, but how to be transparent, to whom and at what context. Context matters. One size does not fit all. Not all AI system requires in the same level of transparency. In low risk application like music or video recommendation, users may prioritize convenience, performance over deep explanation. In high risk applications such as healthcare, finance, hiring or law enforcement, transparency becomes non-negotiable. This lead to the idea of dependent transparency. Instead of demanding full interpretability everywhere, we ask what is at stake, who is affected, what level of explanation is meaningful and actionable. How the AI community address the transparency today. Researchers and practitioners have developed several strategies to manage these trade-offs. One approach is post-hoc explanation, where the system itself remains complex but additional tools are used to explain its outputs. Techniques like features, importance scores, or explanation attempts to answer questions like which factors influence these decisions the most. Another approach is the human in loop systems, where AI supports system decision makers rather than replacing them entirely. In this system, transparency helps humans understand when to trust the AI and when to override it. There is also growing emphasis on governance and regulations. The bigger picture transparency as a balance, not a binary. It is tempting to frame the debate as a simpler choice, transparent AI versus black box AI. But this framing is misleading. Transparency is not a binary property, it exists on a spectrum. The real challenge is finding the right balance between transparency, performance, and safety and fairness. Responsible AI design is not about maximizing a single metric, it is about understanding trade offs and making deliberate context aware choices. To conclude, transparency in AI is essential but is not free. It improves trust, fairness, accountability, safety. At the same time, it can reduce performance, expose vulnerabilities, and create false confidence if handled poorly. The future of AI does not lie in choosing transparency over performance or performance over transparency. It lies in knowing when to prioritize each and in designing systems that respect human values while acknowledging technical realities. Ultimately, the question we must keep asking is not can we build powerful AI? It is can we build AI that deserves our trust? Now, AI as a decision maker, not just tool. We often talk about AI as a tool, something we use, but in reality, AI increasingly decides for us. It decides which resume are shortlisted, which customers are flagged today, which content reaches our screens, which route ambulances takes. In this situation, humans don't take the final call. They often accept what the system outputs. And here's the problem. When decisions move from humans to machines, explanations disappear. A human decision maker can be questioned, an AI system usually cannot. This is why transparency matters, but also why it becomes complicated. Why transparency sounds good in theory. Transparency promises three comforting ideas. First, it promises control. If we understand a system, we believe we can control it. Second, it promises fairness. If decisions are visible, bias can be challenged. Third, it promises confidence. People still feel safer when they know they have something or somewhere or something has already happened. On paper, transparency feels like the obvious solution, but AI does not operate like human reasoning. Why transparency is difficult in practice? AI systems don't think step by step the way humans do. They detect correlations, not reasons. They optimize outcomes, not explanations. When they demand transparency, we are often asking AI to translate mathematical behavior into human logic, and that translation is imperfect. In many cases, the system does not actually know why it made a decision. It only knows the statistically the decision words. This creates the first major trade-off. Do we want explanation that are accurate or explanation that are understandable? The illusion of transparency. When here's an uncomfortable truth. Sometimes transparency is not about understanding, it's about reassurance. Explanations are simplified, complex behavior is reduced to a few variables, and humans feel satisfied. In these cases, transparency becomes a storytelling exercise, not a truth revealing one. This leads to dangerous outcomes. People stop questioning systems like they think they would understand. So the trade-off here is not technical, it is psychological. Efficiency versus accountability. Another major trade-off is speed versus responsibility. AI systems are adopted because they are fact, scalable, and consistent. Transparency includes friction, reviews, audits, explanation, human oversight. Each of these slows down the system down. In industries where speed equals profit, transparency can feel like a burden rather than a benefit. So organization quietly optimizes for efficiency while publicly endorsing transparency. Who really benefits from transparency? Transparency is often presented as something that benefits everyone equally, but that's not true. Different groups want transparency for different reasons. Users want explanations, regulators want compliance, developers want debugging, companies want trust. These goals sometimes conflict. For example, a system that is transparent enough for regulators may still be confusing for users. A system that is satisfied that may reveal too much to competitors. So transparency is not a real demand, it is negotiation between interests. Selective transparency. This brings us to an important idea: selective transparency. Not all orphan or information should be visible to everyone at all times. Instead, transparency should be role based, risk based, and context specific. A doctor may need deeper explanation than a patient. A regulator may need access that their users don't. A high risk decision may require more transparency than a low risk one. Full transparency everywhere is unrealistic. Rethinking trust in AI. We often assume that transparency automatically creates trust, but trust does not come only from understanding. We trust airplanes not because we understand aerodynamics, but because systems are tested, regulated, and accountable. Similarly, trust in AI comes from full transparency and more from robust governance, oversight, and responsibility. The real trade off. So, what is the real transparency trade off in AI? It is not simply between black box and white box, accuracy and explainability. The real trade off is between control and complexity, comfort and correctness, speed and responsibility. Every AI system sits somewhere on this spectrum, and choosing where it sits is not a technical decision, it is a human one. Transparency in AI is necessary but insufficient on its own. It can reveal problems, but it can also hide them behind comforting explanations. It can empower users, but it can also overwhelm them. It can improve trust, but it can also replace accountability. As AI continues to shape decisions at scale, the challenge before us is not to make AI fully transparent, the challenge is to make AI answerable. Thank you.